What's up, everyone? This is Wallace. I'm on vacation in Venezuela right now, but I thought it would be nice to record at least one podcast while I was out. Today it's going to be about redox reactions. So these are pretty important in biology, especially when you have cellular respiration and glycolysis. So we're going to just dive in. First thing you need to know is oxidation. It's the loss of electrons. And reduction is the gain of electrons. We're talking about atoms and molecules here. Reduction and oxidation, they always happen at the same time. And when this happens, we get a redox reaction. So, we'll start off with an example. Copper oxide plus hydrogen gas yields copper and H2O. How does this happen? Well, first let's take a look at the oxidation states of each element. First, with copper oxide, we have copper has a +2 oxidation number, while oxygen has a -2 oxidation number. Hydrogen has a 0 oxidation number. And on the right side, we have copper has a 0 oxidation number, and hydrogen has a +1 oxidation number, oxygen has a -2. What happened? Well, as you can see, the copper went from +2 to 0. That means it decreased. That means copper is being reduced, which means that copper is gaining electrons since its charge is becoming more negative. At the same time, hydrogen is being oxidized. Its oxidation number went from 0 to +1, meaning that it lost electrons. That was an example. Here's another example. We'll go a little more in detail this time. Hydrogen gas plus fluorine gas yields 2HF. On the left side, we have hydrogen has a 0 oxidation number, so does fluorine. On the right side, we have hydrogen has a +1 oxidation number and fluorine has a -1. What happened here? It's easy to see. Fluorine is being reduced since its oxidation number went from 0 to -1. It decreased, it got some electrons. At the same time, hydrogen is being oxidized. Its oxidation number went up 1, which means that it lost electrons. Now some more terms here. Hydrogen is the reducing agent since it is oxidized. Fluorine is the oxidizing agent because it is reduced by hydrogen. Now, the general flow of electrons. Hydrogen gives electrons to fluorine. The element that's being oxidized gives electrons to the element that's being reduced. So here's a more visual way of looking at it. Before the reaction, we have two molecules, one of H2 and one of F2. Obviously, both are filling their valence shells with electrons, and they're both completely stable and have no charge. But when you mix them together, the hydrogen split and the fluorine split. On the left, we have H2 plus 2 electrons and F2 minus 2 electrons. As you can see, the hydrogens have gained electrons while the fluorines have lost them. What happens to these electrons? They get transferred. The hydrogens send their electrons to fluorine. Hydrogen is oxidized since it lost electrons. Fluorine is reduced because it gained electrons. After the reaction, we have two molecules of HF. Fluorine is reduced and hydrogen is oxidized. So, here's a quick recap. When an element's oxidation number is increased, it is oxidized, meaning it's the reducing agent. When an element's oxidation number is decreased, it is reduced, meaning it's the oxidizing agent. Or, to help you better, oil rig. It's a little acronym, meaning oxidation is loss, reduction is gain. We're talking about electrons. When it's oxidized, it loses electrons. When it's reduced, it gains electrons. And, well, that just wraps up our redox reaction podcast. Hope it kind of explained things more for you. Well, that's Wallace signing out. Remember, as always, the more you know, the better you are.